versus chemical properties. So if you want to go ahead and turn in your notebook to that page, that way you can fill out the blanks as we go along. By the end of this video, you need to make sure that you can differentiate, that means tell the difference between physical versus chemical properties. Okay, so how are they different? A physical property is something that describes the substance itself. So I could look at this boy in the video and say, oh, well, he has red hair, or he wears glasses, or he has on a green shirt. These are all physical properties that describe this boy. What's important about a physical property is that they can be observed without actually changing the boy. So I can see that he has red hair, I can see that he's wearing a green shirt, and it doesn't change him at all. Also keep in mind that an observation doesn't have to be just something that you see. It can also be something that you smell or touch or taste, anything that you observe with your five senses. A chemical property, on the other hand, is different because a chemical property describes the ability of a substance to change, to form a new substance, and that chemical property is how it changes. So what does it do when it becomes something new? Okay, there are several physical properties listed here. If you thought about it, I'm sure you could come up with a few more. I know that a lot of these, you know what they are, but some of them you might have forgotten. Like, for instance, let's see. Mass, volume, density, color, these are all pretty self-explanatory, but do you remember what the word malleability means? If something is malleable, that just means that it can be shaped into something, like copper or aluminum are malleable because I can take them and hammer them or fold them into something. If you look around my classroom, you're going to see on top of the shelves some aluminum foil sculptures that some of my students have made over the years. Another word that you may have forgotten is ductility. Ductility just simply means that it can be stretched or formed into a wire. So this is a great property of metals that we use because most of our houses have copper wiring in it. That only works because copper is ductile. It can be stretched very thin. Then there's boiling point, melting point, solubility. That means, let's see, where am I at here? Solubility. That means, can it be dissolved? I really don't write that messy. And that went off the screen. Anyway, can it dissolve in something else? Viscosity is another one. Viscosity is one that students all the time forget. It basically means how resistant is a substance to flow. So if you pour it, does it pour quickly or does it pour slowly? So for example, if I take a glass of water and I pour it, the water is going to flow very quickly. So it has a low resistance to flow, so we say it has a low viscosity. If I take out a bottle of honey and I pour the honey, that honey is going to flow a lot slower, so we say it has a high resistance to flow, a high viscosity. You get the idea. And then hardness and conductivity. So these are just a few of the physical properties that we discuss a lot in chemistry. Okay, there are a couple of things though that you need to keep in mind. Now that you are sophomores and juniors, I want you to know something really well, not just a little bit. And what I want you to know is that physical properties are not always the same. You may think that they are, but when we see a value like this substance has a density of 2.7 grams per centimeters cubed, that value was measured at a specific temperature and a specific pressure. There's something called STP that stands for standard temperature and pressure. So if that temperature and that pressure changes, then that value might actually change. And you know about this, you just didn't realize you knew about this. So for example, how many of you eat spaghetti? I love spaghetti. I used to live, before I lived in Lubbock, well actually in between living in Lubbock. I lived in Lubbock and then I moved back. But I used to live in Laramie, Wyoming. And Laramie, Wyoming has an elevation of 7,200 feet. So when I made spaghetti for my family in Laramie, Wyoming, and I went to boil the water to make the noodles, it boiled a lot faster. That's because at 7,200 feet, I'm a lot higher up than I am in Lubbock. So the higher up I am, the less air pressure I have pointing down on me. So if there's less air pressure pushing on me, then that means that the temperature, the boiling temperature, is going to be lower. The water actually boils at 92 degrees Celsius in Laramie. Now if I make spaghetti in Lubbock, Texas, we are at, let's see, I think about 30, let's just say 32. It's somewhere between 3,000 and 3,500. Anyway, so let's say 3,200 feet above sea level. So if I make spaghetti here, I hope we're not that hungry because it takes a little bit longer. The boiling point of water here is actually, I think, 97 degrees, something like that. Now, if I ask you what's the boiling point of water, pure water, you would say, hopefully, 100 degrees Celsius. That 100 degrees Celsius is the physical property that you know about, but it is measured at standard temperature and pressure. The pressure is at sea level. So if you're above sea level, that's actually going to change. So just keep that in mind, that when you see a physical property, if it has a numerical value, that numerical value could change. Another one that we just talked about was viscosity. So viscosity is how fast it pours. Well, if I take that honey out of the pantry, it's going to pour slow. But if I take it out of the refrigerator and it's cold, it's going to pour even slower than that. So that's just something that I want you to keep in mind. Physical properties are measured at STP, standard temperature and pressure, and so some of them really will vary depending upon the conditions that you measure them in, and we'll talk a lot more about that later. Okay, some chemical properties are pH. That's going to be the acidity of a substance. So is it an acid? Is it a base? And we have a whole unit about acids and bases. So pH measures the acidity. Reactivity, that is, how does it react with other elements? First of all, will it react, or will you just mix it together and nothing? Will it react readily, easily, quickly, slowly? So reactivity is a chemical property. Flammability, that's going to be, will it catch on fire or not? And then of course toxicity. And toxicity is something we all think about because you want to know, well, how much would I have to swallow of this, Miss Allen, before it killed me? That's a question I get all the time. If I get just a little bit on me, will that hurt? Or yeah, so toxicity is something that we talk about. It's how poisonous is it. Okay, something to keep in mind about chemical properties is that a substance always retains its chemical properties. So for example, wood is flammable even if it's not on fire. I still know that it will catch on fire, right? So that means that it has a chemical property of flammability even if it's not on fire. Something is poisonous even if I don't swallow it to see if it's going to hurt me. Okay, so now let's see what you've learned. Each one of these properties is either going to be physical or chemical. I want you to decide what you think it is. Look back at your notes, and if you don't know, then when you come to class tomorrow, I want you to ask me, okay? Dissolves in water. Would that be physical or chemical? Ability to explode, except in chemistry we say combust because that sounds fancier. Reacts with an acid. Would that be physical or chemical? And lastly, pungent odor. What does that mean? That means it's stinky. Okay, congratulations, you just made it through your first video. I'll see you in class tomorrow.